Welcome to our deep dive into the fascinating world of clouds. Today we'll explore everything from their formation to their role in weather patterns. These fluffy, sometimes menacing formations are intricate wonders of nature. So buckle up as we embark on this journey to uncover the secrets hidden within these celestial cotton balls. So what exactly is a cloud? A cloud is a visible mass of tiny water droplets or ice crystals suspended in the atmosphere. Think of it as floating fog. These droplets are held aloft by air currents, creating shapes in the sky. Clouds are key in Earth's water cycle, carrying moisture globally. They influence weather, bringing rain or storms. Clouds regulate temperature by reflecting sunlight and trapping heat. Cloud formation is a fascinating process driven by a simple concept: condensation. As warm, moist air rises, it cools down. Now, colder air can't hold as much moisture as warm air, so as the air cools, the water vapor in it starts to condense. This means that the gaseous water vapor transforms back into tiny liquid droplets, clinging onto microscopic particles in the air like dust or pollen. These droplets then clump together, forming the visible masses we call clouds. The higher the humidity, the more moisture is available for cloud formation. We know clouds are formed by condensation, but what exactly are those fluffy white masses made of? Well, primarily clouds are composed of tiny water droplets or ice crystals, depending on the temperature at their altitude. Lower, warmer clouds are mostly made of water droplets, while higher, colder clouds are composed of ice crystals. Clouds can also contain other particles like dust, pollen, smoke, and even pollutants. Clouds can form at various altitudes, from near the ground to high up in the atmosphere. Low-level clouds, like stratus and cumulus clouds, form below 6,500 feet and are often composed of water droplets. Mid-level clouds, like altostratus and altocumulus, form between 6,500 and 20,000 feet and can consist of both water droplets and ice crystals. High-level clouds, like cirrus and cirrostratus, form above 20,000 feet and are typically made of ice crystals. These high-altitude clouds often create beautiful halos around the sun or moon. Have you ever wondered how clouds stay afloat? It's due to buoyancy and air currents. Tiny droplets are less dense than air, creating buoyancy. Air currents also play a role. Updrafts lift cloud droplets. These updrafts are caused by convection, orographic lifting, and the weather fronts. Clouds come in a dazzling array of shapes and forms, from fluffy cotton balls to wispy streaks to towering thunderheads. These shapes are not random, they are determined by the atmospheric conditions in which the clouds form. For example, cumulus clouds, those puffy, white clouds we often see on sunny days, form in unstable air with rising thermals. Stratus clouds, on the other hand, form in stable air with little vertical movement, resulting in their flat, sheet-like appearance. Strong winds can stretch and distort clouds, creating elongated shapes like cirrus clouds. Ever looked up at a bright, sunny day and wondered why those fluffy clouds are so brilliantly white? The answer lies in the way light interacts with the tiny water droplets and ice crystals that make up clouds. When sunlight, which contains all colors of the rainbow, hits a cloud, it gets scattered in all directions by the water droplets and ice crystals. Because all colors are scattered equally well, our eyes perceive the scattered light as white. We've all seen those ominous dark clouds that often signal an approaching storm. As a cloud grows thicker and denser, less sunlight can penetrate through it. The water droplets and ice crystals within the cloud absorb and scatter more light, preventing it from reaching our eyes. This lack of transmitted light makes the cloud appear darker, especially when viewed from below. Clouds form at various altitudes, from near the ground to the edge of space. Low-level clouds like stratus and cumulus form below 6,500 feet. These clouds often obscure tall buildings. Mid-level clouds like altostratus and altocumulus form between 6,500 and 20,000 feet. High-level clouds like cirrus and cirrostratus form above 20,000 feet. These clouds are made of ice crystals and appear wispy. How can something as seemingly light and fluffy as a cloud actually be heavy? A single cumulus cloud can weigh as much as a Boeing 747 jumbo jet. The key lies in the incredibly small size and weight of individual water droplets and ice crystals. Have you ever noticed that while clouds come in all sorts of shapes and sizes, they often have a strikingly flat bottom? It's as if there's an invisible ceiling up in the sky that clouds can't seem to penetrate. This phenomenon is due to the way temperature and pressure interact in the atmosphere. As warm, moist air rises and cools, it eventually reaches a point where the temperature and pressure are just right for condensation to begin. Since the temperature and pressure are relatively uniform at this altitude, the cloud base tends to be flat. Clouds are essentially floating reservoirs of water, but the amount of water they hold can vary dramatically depending on the type of cloud and its size. A small cumulus cloud might contain a few hundred tons of water, while a large thunderstorm cloud or cumulonimbus can hold millions of tons of water. Clouds are classified into 10 main types based on shape, altitude, and precipitation. Let's look at some common types. Cumulus clouds are puffy and white, seen on sunny days. They have flat bases and rounded tops. Cumulus clouds can grow into cumulonimbus clouds, bringing thunderstorms. Stratus clouds are flat and cover the sky. They can produce light rain or drizzle. Cirrus clouds are wispy and form at high altitudes. They often indicate fair weather but can signal an approaching front. Beyond the main cloud types, there are unique formations that capture the imagination. Lenticular clouds. These smooth, lens-shaped clouds form over mountains, creating wave patterns, often mistaken for UFOs due to their unusual shape. Mammatus clouds. These pouch-like clouds hang from thunderstorms and are a rare sight, formed as cold air sinks into warmer air, creating distinctive pouches. Nacreous clouds. Iridescent clouds in the stratosphere at very high altitudes. Earthquake clouds are a controversial topic, with some people claiming that certain cloud formations can predict earthquakes. However, there is no scientific evidence to support a direct link between clouds and earthquakes. The idea behind earthquake clouds is that stresses in the Earth's crust before an earthquake release gases that rise into the atmosphere, influencing cloud formation. While some unusual cloud formations might coincide with earthquakes, this is likely coincidental. Not all clouds bring rain, but some are more likely to unleash a downpour than others. Nimbostratus clouds. These dark grey clouds are the quintessential rain clouds. They form in thick layers, often covering the entire sky, and produce steady, prolonged periods of rain or snow. Cumulonimbus clouds. These towering thunderstorm clouds are capable of producing intense downpours, hail, and even tornadoes. Altostratus clouds. These mid-level clouds can sometimes produce light rain or snow, but their precipitation is typically less intense than nimbostratus or cumulonimbus clouds. While some clouds bring gentle rain, others signal the arrival of powerful storms. Cumulonimbus clouds, also known as thunderheads, are the most obvious storm sign. These towering giants are characterized by their anvil-shaped tops, which form as strong updrafts push the cloud top into the stratosphere. The presence of mammatus clouds, those pouch-like formations on the underside of a thunderstorm, is another indication of a powerful storm. Rapidly darkening skies, a sudden drop in temperature, and a shift in wind direction are all additional signs that a storm is approaching. Thanks for joining us on this journey through the sky. We hope you now have a better understanding of the incredible world of clouds, from their formation to their role in weather patterns. Clouds are much more than meets the eye. Keep looking up and never stop exploring the cosmos.